Hello and welcome back to Mathematics and the Sciences. Today we're going to be starting a 4-part video series covering a basic overview of algebra. In this first video, we will be discussing what algebra is, as well as building up a basic foundation for algebra. In the next video, we will be discussing patterns and relations in algebra. In the video after that, we will be covering topics such as graphing in algebra. Then in the final part of the video series, we will go through each concept we have learned in the previous 3 videos and talk about how each of these can be seen as an abstraction or generalization of arithmetic. There are timestamps down below if you'd like to skip through the video, or if you want to save your spot and come back at a later date. I've also published a video which talks about the basics of arithmetic, as well as another video where I went through and outlined each topic in math from beginner to advanced. If you have any questions or comments, feel free to ask them in the reply section down below. Now let's get into some algebra. What is algebra? Algebra is the branch of math that deals with abstract symbols to describe relations and patterns. We can manipulate these symbols using arithmetic and other rules to change our patterns and then model other real-world phenomena as well. In high school and middle school, the algebraic concepts and topics we learn are typically broken into 3 classes: pre-algebra, algebra 1, and algebra 2. We can also study algebra in college, and 2 common classes that we would see would be intermediate algebra and college algebra. Intermediate algebra acts as a semester-long summary of algebra 1 and 2. College algebra then dives deeper into the algebraic concepts we have learned in previous classes and also introduces new ideas of its own. So why should we learn algebra? There's this idea in modern society that a lot of the education we gain will never be used in the real world. We have this notion that it's simply about remembering enough of a subject to get a good grade, and then we can completely forget the information. However, math is one of the most useful tools you can learn. Not only is it extremely applicable, but it also helps you develop better critical thinking skills. Plenty of other subjects require that you know algebra, or at the very least the basics of algebra. So algebra, and math in general, will act like gateways into other subjects. Algebra specifically will help you learn statistics, chemistry, physics, aspects of biology, finance and business, computer science, medicine and healthcare, and of course, engineering. A large piece of algebra is getting used to thinking abstractly. This might not be something that is explicitly stated by your teachers, but algebra is a very important step when it comes to being able to abstract and generalize ideas. Now let's build up the foundations for algebra. It's important to note that algebra is built upon arithmetic, and before we can really dig into algebra, we must take some time to ensure that we have the basics of arithmetic down. This includes defining some terminology, and then discussing other concepts related to manipulating equations. Let's first begin by looking at the statement 2 plus 3 equals 5. So our first piece of terminology would be a mathematical statement. And a mathematical statement is a declarative sentence that asserts a fact or makes a claim that can either be true or false. This would include equations, inequalities, conjectures, theorems, and logical statements. Our above statement is an example of an equation. An equation is a mathematical statement that claims the equality of 2 expressions. Our expressions make up the left and right halves of the equation, and they are split by an equal sign. In the example above, our expressions would be 2 plus 3 and 5. And here we see our equal sign or equality sign in the middle. And our equal sign describes the relation between the 2 halves. Specifically, our equal sign lets us know that everything to the left of the sign is worth the same numeric value as everything to the right of the sign. So essentially what we're saying is we have an expression on the left, a symbol which lets us know the relationship, and another statement on the right, or an expression on the right of every equation. Sometimes you'll see different symbols in the middle, such as equality symbols, but this is going to be essentially how it breaks into. Now we're going to look at another example. So we're going to have the equation 3 minus 2 times 3 plus 7 equals 2 plus 2. And what we're doing here is we're verifying both sides have the same numeric value. And we're going to go ahead and begin with the left-hand side, and then we'll come back and we'll do the right-hand side. So here we have 3 minus 2 times 3, which is 6, plus 7. And we're going to go ahead and group together like terms. So here we have an addition, or a positive number, and here we have a positive number. So we know 3 plus 7 is 10. And then here we have minus 6, and we know 10 minus 6 is just 4. And then on the right hand side we have 2 plus 2, and we know this is just going to be equal to 4. So we've shown that the left hand side is equal to 4, and the right hand side is equal to 4. So we have verified that both sides have the same numeric value. And here we just went through and used basic arithmetic to show that these are equal. Now let's define another piece of terminology. Each of our expressions can be broken down into terms. Our terms are the groups of numbers within an expression that can be split up by addition and subtraction operators. We can look at our last equation to find an example of this. And so we had 3 minus 2 times 3 plus 7 equals 2 plus 2. And we're going to go ahead and start on the right. 2 plus 2. So here, 2 and 2 would be our terms. And that's it. And then on the left, we can go ahead and look at these. And so we have 3 minus 2 times 3 plus 7. And it's important to note here that subtraction can be thought of as adding a negative number. So if we simplify this into 3 minus 6 plus 7, then we can rewrite this as 3 plus negative 6 plus 7. And now we're going to go ahead and look at each of our terms. So our first term would be 3, our second term would be negative 6, and then our third term would be 7. However, if we want to keep it in the terms of this multiplication here, then it would be 3, negative 2 times 3, and 7. There are also different ways to categorize terms. However, we will talk about that a little later on. Now that we are comfortable with basic terminology, we can discuss manipulating our equations in a new way. Let's look again at our original equation. 2 plus 3 equals 5. Using basic arithmetic tools, we were able to verify that these two expressions are equivalent or equal to each other. That being 2 plus 3 and 5 have the same numeric value. However, it's important to note that when we are learning arithmetic, the goal is going to be finding another expression which is equivalent to the one we are given. This would be something like 2 plus 3 equals what? And then you would have to find this. The reason why I began with a complete equation is so that this next concept will become a little bit easier to grasp. Let's look again at our original equation. 2 plus 3 equals 5. Here our equal sign allows us to do something pretty special. Since both sides of the equation have the same numeric value, we are allowed to add and subtract as long as we are doing the same thing to both sides. The key is that the manipulation must be equal on both sides. If we add 2 from one side but subtract 5 from the other side, then this manipulation will not work because it's not balanced. Let's give an example of what exactly we are saying here. We will begin with our original equation, and we will do a simple manipulation. Since we already know that 2 plus 3 equals 5 is a correct statement, we can now manipulate this. We're going to subtract 2 from both sides of our equation. Here we know that 2's would cancel, and so we would be left with 3 equals 5 minus 2. And then we're going to go ahead and verify this. We know that 5 minus 2 is in fact 3. And so here we have two equations now. And we see that our two equations are actually stating different facts. Our first equation is stating that 5 equals 5, and our second equation is stating that 3 equals 3. However, despite these equations claiming two different things, we are able to still say that they are equivalent. This is because they pass two checks. The first check is making sure that both equations are correct by verifying them. We know, of course, that 2 plus 3 equals 5, and we know that 3 equals 5 minus 2. And when we simplify, we get the same numeric value on both sides. They have maintained the equality of the two expressions which make them up. So they both pass the first test. The second check is to make sure that we can transform one into the other by using arithmetic operations. Here we know that we can transform 2 plus 3 equals 5 into 3 equals 5 minus 2 by doing exactly what we did here, subtracting 2 from both sides. So we know that the two equations also pass the second check. Since they pass these two checks, we can state that the two equations are equivalent to each other. We can also do this transformation process with addition and subtraction, like we have shown above, but we can also do this with multiplication and division as well. Let's go ahead and use our original equation one more time to show how we can manipulate both sides using division. So here we're going to state 2 plus 3 equals 5. And we're going to divide both sides by 5. So we're going to divide 2 plus 3 by 5, and we're going to divide 5 by 5. This is typically how it's going to be written in lower classes, like beginner algebra classes, Algebra 1, maybe Algebra 2, but when you get to more advanced classes like calculus, you might see this similar process be written in a slightly different way, such as 2 plus 3 equals 5, and then off to the right, we're going to see a little multiplication x, a bar, and then whatever we're multiplying by. And here we're saying we're multiplying both expressions by 1/5. And you can distribute this in now. So this would be 2 over 5 plus 3 over 5 equals 5 over 5. And now we can go ahead and combine like terms and simplify. So this would be 2 plus 3 over 5. Since they share a common denominator, we're allowed to put them under the same denominator. And then 5 divided by 5 is 1. However, most of the time we're probably going to skip this step here and go straight to this step. And the entire reason why we write this in the first place is for clarity, because sometimes it can be kind of hard to see what a person has done to manipulate the equation, and we're just going to skip straight here afterwards. And this helps teachers keep track of what has been done to the equation. Now we can go ahead and simplify this further. We know that 2 plus 3 is 5, so we have 5 over 5 equals 1, and 5 divided by 5 is 1. So we have verified that this manipulation technique will lead to an equation that is verifiably true, meaning that this is okay to do, and that 1 equals 1 is an equivalent expression to 5 equals 5, or 2 plus 3 equals 5 is an equivalent equation to 2 plus 3 over 5 equals 1. It's important to note that when we divide and multiply, we're doing this to all the terms in both sides. This is different from addition and subtraction because in addition and subtraction, we are creating a new term and then we're using that new term to try and simplify our other expressions. Before moving on, we're going to show one more equation and its manipulation and highlight the previous comment of multiplication being applied to both terms, as well as addition creating new terms. And we're going to examine the second example that we gave, this being 3 minus 2 times 3 plus 7 equals 2 plus 2. Here I want to show that the above equation can be transformed into 2 equals 2. However, there's a caveat. I'm not going to allow myself to use any normal arithmetic unless it's done after the manipulations, meaning I can't simplify these sides until after I move something over. It's important to note that I'm only doing this to highlight the skills that we've learned up until this point. In your regular algebra classes, it's a smart idea to simplify whenever possible, and use these manipulation techniques only after all of the other simplification has been done. Okay, so we're going to begin by moving this over to the other side. And essentially what we're doing is we're going to add 2 times 3 to both sides of our equation. And so we would get 3 minus 2 times 3 plus 7 plus 2 times 3 equals 2 plus 2 plus 2 times 3. Although we have a multiplication symbol here, we're still adding this entire term to both sides. And we learned earlier that this is its own term, so we're allowed to do that. And now we're just going to reorder this equation so that it makes a little more sense. So we're going to have 3 plus 7 plus 2 times 3 minus 2 times 3 equals 2 plus 2 plus 2 times 3. Here we see that these are the same thing, so we're allowed to cancel them out. And we know that 1 minus 1 is equal to 0, and in the same way, if we were to multiply these out, this would be 6 minus 6 equals 0. So now we can simplify this, and we're going to go ahead and put that 0 into the equation. So we also know that anything plus a 0 is just going to be whatever that thing is. So our 0 here is going to disappear, and we're going to be left with 3 plus 7 equals 2 plus 2 plus 2 times 3. Now we're going to subtract both of these 2's from both sides. And we're not going to combine them together, just to showcase another idea. So we're subtracting 2 and another 2 from both sides. Again, we can cancel these out, and we're left with 0 plus 2 times 3, which is just 2 times 3. So on this side, we have 3 minus 2 plus 7 minus 2 equals 2 times 3. And so we're going to group these together, and then we're going to use a little bit of arithmetic. So 3 minus 2 is 1, and 7 minus 2 is 5. And this is going to be equal to 2 times 3. The only thing we have left to do now is to divide both sides by 3. So here we would have 1 plus 5 divided by 3 equals 2 times 3 divided by 3. It's important to note that we can actually go ahead and rearrange this slightly. And we can use our associative property, which basically means we can reorder our equations as long as it's still correct. So because we have a separate term up here, we can't divide only one of these terms by 3. If we were to break this up, we'd have to do 1 divided by 3 plus 5 divided by 3. But multiplication is slightly different. Here, we're allowed to pull the 2 out and then multiply it in. And so, here, let's give a little bit of an example. So 6 divided by 3 is going to be 2, because 3 goes into 6 2 times. But we also know that 2 times 3 over 3 is the same as 2 times 1, which is equal to 2. And that's the associative property. We're allowed to pull this out. And there's also an associative property for addition. This is the associative property for multiplication. So here we have 1 plus 5 divided by 3 equals 2 times 3 over 3. This goes to 1, and we're left with 1 plus 5 divided by 3 equals 2. And now we're just going to go ahead and add these and simplify. So 1 plus 5 is 6, and we know that 6 divided by 3 is 2. So this is 2 equals 2. And so we have shown that our original equation, 3 minus 2 times 3 plus 7 equals 2 plus 2, can be transformed into 2 equals 2. And we've also shown that every single step we've done here is correct because we end up verifying that 2 equals 2. And remember, with arithmetic, we can simply use our tools of addition, subtraction, multiplication, and division to solve directly before applying our tools of manipulation. However, the skills that I've taught you here are going to be very essential when we start going over the actual algebra. Now that we've learned how these manipulations and transformations work, we can start actually diving into algebra. We've built this foundation for algebra that's going to make it really, really simple to understand what's going on. And so in algebra, typically we're going to be given an equation where one or more of the terms is an unknown, and we have to work to solve that value of the term and what it's equal to. We call these unknowns variables. And they are represented with letters such as X, Y, or Z. These are the common letters to use. However, you can pretty much use any letter as long as it's clear that it's a variable. Here we have two examples that we're going to go through. So 2 plus x equals 5, and 3 minus x over 2 plus 7 equals 4. So our variables are placeholders for numeric values. We can think of them as being mystery boxes, and by solving an algebraic equation, we can discover what that number is in the mystery box. After going through the process of learning how to manipulate numbers in a new way, we can start to see why this is so valuable in algebra. These manipulation techniques allow us to solve for these unknowns super easy. So here we're going to look at our first equation. 2 plus x equals 5. And so we know that to find the value for x, we're just going to simply move this 2 over. And to do that, we're going to subtract 2 from both sides. So here we get 2 minus 2 plus x is equal to 5 minus 2. And of course, this is going to be 0, and we're left with x equals 5 minus 2, and so x equals 3. And now after we've solved what our variables are equal to check to make sure that we got the right answer, we can simply plug our variables back into this equation. And so 2 plus 3 equals 5. And we know from the other parts of this video that this is a true statement because 5 equals 5. Both expressions share the same numeric value. Now let's go ahead and look at this second equation here. Let me see if I can copy this. Perfect. So we're going to do our second equation now. Became a little wonky there. Let's just move this. It's okay, it's salvageable. Alright. So here we have 3 minus x divided by 2 plus 7 is equal to 4. And so again, we're going to simply see what we can do to simplify this first. We see that we have 3 plus 7, which can be simplified into 10. So this is the same as 10 minus x over 2 equals 4. And we're going to go ahead and move this 10 over now. So this 10 is going to go over here. And to do that, again, we're going to subtract 10 from both sides. So we have 10 minus 10 minus x over 2 is equal to 4 minus 10. Remember, it's important to do whatever you can to simplify the terms first before dividing or multiplying. So here, 10 minus 10 is just going to be 0. So we have negative x over 2 is equal to 4 minus 10 is negative 6. And so to get x by itself now, what we're going to do is multiply both sides by negative 2. And so we see that this ends up being x equals 12. And again, we can verify this by plugging it into this equation. So 3 minus 12 over 2 plus 7 equals 4. So this is 10 minus 6, 12 over 2 is 6, equals 4. And we know this is a true statement. It is logically correct because both sides are equivalent. And so when we're looking at our algebra problems here, we're going to really focus on isolating this variable, especially if there's only one variable. And that's pretty much how you solve these equations. You isolate them. It's important to note that there's a couple of different ways you can do this. So like with this equation here, 3 minus x over 2 plus 7 equals 4, we could also simplify. So 10 minus x over 2 equals 4. And then we could straight divide this, or multiply, instead of moving the 10 over. So we could do 10 minus x over 2 equals 4, and multiply both sides by -2. But when we do this, it's important to note, we also have to multiply this to every single term. So this includes this 10 here. So this 10 is going to get multiplied by -2. This x over 2 is going to get multiplied by -2. And then our 4 is also going to get multiplied by -2. So we have -20 plus x, because this -2 is going to change this sign, equals -8. And now we're going to move this 20 over. So we're going to add 20 to both sides. If this is negative, we're going to add. If it's positive, we're going to subtract. And so we see -20 plus 20 plus x equals -8 plus 20. And so here, our 20s would cancel to be 0, and we're left with x on the left-hand side. And then -8 plus 20 is the same as 20 minus 8, which is 12. And so we got the same answer. It's important to note, once again, that if you're going to do this, you have to do it to every single term. So if we had 4 plus x on this side, we would also have to multiply this x by -2. And that's the difference between multiplication and addition. Addition, you're only creating a new term, which you can use to simplify. And then multiplication, you're using whatever manipulation you did to every single term. Now we're going to go back and define some of the different types of terms that we have and the components that make up a term. So earlier in the video, I said we were going to define terms later on, or at least what terms are broken into later on. And so to begin with, we have, let's change this color. So to begin with, we're going to write terminology. And our first term is going to be a constant. A constant is a number which has no variable component. So for example, we would have 5 plus 3 equals 8. All of these are constants. There's no variable term at all. Our next term would be a variable. And we kind of defined this already. A variable is an unknown which is represented with a letter such as X, Y, or Z. And these are blank boxes which we are trying to figure out what's in them. I guess they're not blank, but they're mystery boxes, and we're trying to figure out what's in them. And then our final term here, or our second to last term here, is going to be a coefficient. And a coefficient is a number in front of a variable, what it's being multiplied by. So for example, 1/3 x, our coefficient here is 1/3. 7x, our coefficient here is 7. And then if we had something like negative 5 over 3x, our coefficient is negative 5 over 3. It's also important to note if you have negative x, again going back to thinking of negatives being addition of negative numbers or subtraction being the addition of negative numbers, our coefficient here is not really stated, but it would be negative 1. Also, if we have just x, our coefficient, again, isn't really stated, but it would just be 1. And then we have our final piece of terminology, which is going to be a like term. And so a like term is simply a term which shares the same variable as well as the variable's power. For example, I lost my mouse. There it is. So for example, we would have 3 and 5. These are like terms because they don't share any variable component. We would have 3x and 5x. These are like terms because they both share 1x. If you had something like 3y and 3x, these are not like terms because they share different variables. These variables could be equal to each other, but they could also not be equal to each other. And just because they're equal to each other in one equation doesn't mean they're going to be equal to each other in every equation. Likewise, 3x and 3x squared are not the same because x is not always guaranteed to be equal to x squared. And so like terms are the variable as well as the shared power. So 5x to the 8th and 6x to the 8th are like terms. And that's all the terms that I have left. That concludes the first part of the algebra series. We've gone through all of the basics of algebra, and we've built up a good understanding of what algebraic manipulation is all about. And we've also learned some basic principles when it comes to solving simple algebra problems. In the next video, we will discuss more patterns and relations in algebra and dive deeper into the concepts we've learned in this video. Remember to hit that like and drop a sub if you enjoyed this content and want to stay up to date with my videos. Stay tuned and I'll see you all in the next video. Cheers.